Okay, so we can see the zoomed up picture. These were the pictures I was drawing. Here's actually 1 over x. Here's the equation of the tangent line, or here's a graph of the tangent line. Tangent at x equals 2. And nearby, oh, wow, they're really close. That curve looks pretty straight as long as you zoom in. But as soon as you get further out, they get further and further apart. So those values we found in that last video, this was the actual function value. That's 1 over 2.1. That is what we got on the tangent line when we plugged in x equals 2.1. They're pretty close. Okay, let's do that same game here with cube root of x to approximate 8.1. Okay, so cube root of x, we know what his graph looks like. Let's think this through. So here at 8, cube root of x is 2. I'm just going to draw out this tangent line just so we can kind of see what we're doing. So right there, I'm supposed to be tangent. So this is going to give me a pretty good approximation of this function close to x equals 8. It's not going to do me any good down here at x equals 1 or way over here at x equals 1,000. It's going to be a terrible approximation. But as long as I'm near 8, it'll be a good approximation. I'm looking at 8.1. I think I'm going to be okay. So we call this the linearization of the function. And that's f at the starting point plus the derivative at the starting point times the change in x minus the starting point. So in general here, L of x is f of a plus f prime of a times x minus a. And this is the linearization of f at x equals a. Okay, so I need two values. I need f of 8 and I need f prime at 8. F of 8, the original evaluated at 8, cube root of 8. That's 2. Like, why did we choose 8? Why didn't we choose 6.3 to approximate this? Because there's a nearby value. This is the guy I'm actually after. There's a nearby one that I know exactly. That's why we chose to use x equals 8, because I know cube root of 8. All right, now we take the derivative. So the derivative, remember, this is really x to the 1/3 power. His derivative would be 1/3 x to the negative 2/3, or 1 over 3, the cube root of x squared. So f prime at 8 is 1 over 3 cube root of 64. Cube root of 64 is 4. We get 1/12. Pause the video and check through all that arithmetic to make sure you understand where all that came from. Okay, then the linearization, or in other words, f of x is approximately equal to the function value at 8, 2, plus the derivative at 8, 1/12, times x minus 8. So f at 8.1 is approximately equal to 2 plus 1/12, 8.1 minus 8. What is that? 2 plus 0.1 over 12. Now, I'm going to get a calculator out to do this. But if you were back in Isaac Newton's day, You would have to do this arithmetic right here by hand. But that's a lot better than trying to find a cube root by hand. That would take you all day. You would, if you were trying to calculate this by hand, honestly, what you'd have to do is a whole bunch of guess and check. You know, it's around 2. So you would plug in numbers just a little bit bigger than 2 and cube them and keep trying guessing and checking till you get as close as you want to 8.1. That would take you all day. This you could do, like if you're really good at long division, you can do that in a matter of minutes. Right, let me get my calculator, pause. Okay, so our approximation here will be 2 plus 0.1 over 12. 2 point, and they said 5 places. So 2.00833. Okay, that's my approximation. Now for fun, let's use the calculator to see what cube root of 8.1 really is. So 8.1 to the 1/3 power. Come on, that is a fantastic approximation. It's not perfect, but it's really good. Like I'm correct up to rounding here to the 4th decimal place. Now, your calculator, I'm going to give you a little bit of a little background here. Your calculator is not actually calculating the cube root. That decimal goes on forever. This is an irrational number. Your calculator is using a similar process to what we just did, only it's not just doing a linear approximation. It's using a more complicated version of what we're doing, but that's what your calculator is doing, and it's correct out to here. In fact, your calculator is actually storing more digits than this. This is just what it shows us. It actually has in its memory more digits than what it's showing. And it's correct. I don't know how many places, but definitely more than 5 places. Okay, stop that one.